Alright, so I want to do a quick video on how to write launch scripts with Kerboscript. And what we're actually going to try to do for this example is we're going to try to launch this rocket up to 1,000 meters and then have it hover there at 1,000 meters. That requires a little bit of successfully using arithmetic and such, and some control tricks, but we're going to use that as an example because it's different from the goal of launching a rocket to space, and the tutorial launches a rocket to space. So that's what we're going to do. First thing I want to talk about is where the Turboscript files live. So I have my Kerbal Space Program directory at homenatgames ksp 1.9.1. And within that directory, there's a directory called ships. In there's a directory called script, and that is the archive volume for KOS. So if we edit files in there, those files will then be available to copy to our spaceship component. We have our spaceship component that is the scriptable control system here, and this one apparently has 10K of disk space on it that we can use for control programs. So here's my test rocket. It's just got a single rocket engine, some liquid fuel, so we can throttle it up and down and get it to hopefully hover in place. Probably won't work. So once we get in here, I have a couple of other random scripts in here, but we're going to go ahead and write a script to try to hover. And here we are. We're writing a script. Now, before we get too far into how Turboscript works, a couple comments on the language itself. So this language was designed for KOS, and it is supposed to look like an awful programming language from like the 1970s. It's definitely, we can see the influence of like BASIC and COBOL and some of those old languages. And the goal of the developers was to try to make it fit in with the game and try to make it feel like part of a historical space program. And that's sort of fun, but it's also kind of annoying when you have to deal with a language that was definitely designed specifically to troll you for your college course. But that's what's happening. And another thing to keep in mind about that is that Turboscript looks funny, but the actual mechanics of it are very similar to any modern dynamic scripting language like Lua or JavaScript or Python. It just has kind of funny syntax. Now, in order to actually learn the language, I recommend going through the Quick Start tutorial. I recommend reading all the documentation. I actually mean reading all of it. Go to the documentation for KOS, start at the beginning, and just read the whole thing like a book. It's not that long. Some of it, obviously, you want to skim rather than reading in depth, but for learning a new language and platform, when it has nice short documentation like this does, just sitting down and reading it all is a legitimately good thing to do. That means that you have the opportunity to learn about functionality and especially library APIs that you otherwise there'd be no way to know about them other than going and reading everything and then knowing all of what's there, or at least having seen what's there, so you have the chance of then remembering to go look for something specific. So first we're going to launch the rocket. Let me get my notes in place for this. So we're going to lock throttle to 1.0. So that's going to make the rocket actually launch. And we're going to lock steering to up. Now, lock is sort of an interesting mechanic. What lock actually does is it implicitly defines a function that gets run every physics tick in-game. So this is something that Kerboscript is letting us do that we wouldn't normally get to do in most high-level languages. This is the sort of thing that you could produce on a microcontroller by tying something to an interrupt, but lock really is it's evaluating this expression, the like steering to up expression, every single tick. And so you don't want to have a ton of lock expressions, but it makes sure that that you get the behavior that you want. It's like setting something, but it makes sure that it stays set and it updates if there's an expression over on this side. So then we're going to go ahead and stage to launch the rocket. And this is sort of a minimum script. You can see that we have a program as a series of expressions. A program is a series of statements. Each statement is ended with a period because, of course, it is. Erlang thinks that's a good idea too. It's dumb there too, but that's what we have. So now we're going to try to launch our rocket. To do that, we want to go ahead and telnet localhost 5410 is our port number, and you can see that I've enabled telnet here in this KOS widget. So we can telnet localhost, I already forgot what it was, 5410. When we do that, we get this terminal window. Now we could interact with KOS just by using the sort of in-game terminal, but the in-game terminal, the editor that it has is not a top quality programmer's editor. I like Vim. Vim is nice, especially for this sort of streaming thing. But you can use any editor in the directory on the host machine, whereas on the KOS terminal, you just have access to the editor it provides, which is sort of worse than Nano. So we can see here in the telnet menu, it's giving us a list of all of the ships that are currently active that we are able to connect to because they have a control computer part. So we're going to go ahead and pick one from the menu, and now we're connected to the sort of terminal on the control computer in-game. If we type list, we can see there's nothing in here, but if we say switch to 0, and then type list, we're on the archive, and we can see the files here in the archive are exactly the same files we saw back in the ship script directory where we were editing our files. So now we can do copy path 0:/. So 0 is the archive volume. This works sort of like drive letters in DOS did, where we specify volume : and then the path. So I want launch.ks. I want to copy that to the 1 volume. Switch to 1 list. And now on our ship, we have our script. We can then run launch. If the name of the script were complicated enough that it wasn't a nice clean token, we could use run path with a string. Something like that, but using the run statement is nice and clean if we've named our thing in a way that it's a valid token. So now we run launch, and immediately that's the wrong thing. I was supposed to run a thing called hover. Let me copy path. We're still within radio range, so we can go ahead and copy things if I'm quick. Hover.ks. I need to do this before it crashes. Run hover. Oh, my program ended. Alright, I'll kill this. I'll reset this. Route to launch. That'll reset this. We can quit out of our telnet session. And so when we finally did manage to run hover, the problem that we had is it does things, but then, like any computer program, it terminated as soon as we got to the end. So what I actually want to do is just kind of have this loop forever. So until false is the sort of simplest infinite loop we can write. There's no while loop in Kerboscript, but there is an until loop. That actually kind of makes sense because it allows us to do simple scripts where we're going to do until some condition, we're going to do plan A. Once that condition is met, we'll continue on to the next loop, which is going to be another until loop. And then in the loop, we want to make sure that processing happens. So we're going to wait 0.01 or 0.1. That's seconds, how many seconds we're going to wait per iteration. And then we're not even going to do anything in the loop. We're just going to go ahead back and telnet into our thing. Go to 1, copy path, hover to our volume, and then run hover. This is going to launch our rocket. We're going to go straight up, and it's just going to launch up forever until it runs out of fuel. That's not exciting. So let's go ahead and make our hover script do a little bit more. So we want to hover at 1,000 meters. So the simplest strategy is if our ship altitude is less than 1,000 meters. We're going to do one thing, otherwise we're going to do another thing. So if we are less than 1,000 meters, we're going to go full speed. Otherwise, we're going to go no speed. So let's reset our rocket over here. And once we do that, we can try our new script. Copy path, hover.ks over to the ship. Alright, so our rocket's going to launch, and it's going to continue up until it gets to 1,000 meters. And you'll note that it's accelerating the whole time. So when we finally do get to 1,000 meters, we're still going 150 meters per second up. So we're going to continue drifting even after we shut the rocket off, all the way up to above 2,000 meters. Now, we will eventually stop here. 2,225 or so. And now we're falling back down. And we're sitting there in the loop, and so as soon as we get down to 1,000 meters, this thing is going to start firing again. But by the time that happens, we're going almost 100 meters per second. There was some air resistance, so it's a little slower. We're going almost 150 meters per second down, falling down. So when the rocket turns back on at full, we go down to 400 meters before it starts pushing back up again. And it's going to wobble up and down for quite a while here. Every time we do this, it's going to wobble a little bit less, mostly because of the air resistance. But this isn't great. So we'd like to have a little bit more control. So my first question then is, how fast do we want the rocket to be going, or what throttle do we want the rocket to be going when it's hovering? We know how fast we want it to be going. When it's hovering, we want it to be going at speed 0. So let's go ahead and write a control program that will get our rocket to speed 0. And so let's figure out what speed 0 actually is. So to declare variables in Kerboscript, we have two keywords to do it. We have a global keyword, which will declare a global variable. Let me reset this rocket so it's not bouncing up and down while I'm talking. So this will create a global variable here with a value of 5. Local bar is 7. That creates a local variable with a value of 7. And when I say local variable, I mean lexically scoped local variable. Global variables aren't that wildly useful, so we're going to go ahead and focus on local variables. Our mechanism for defining variables is going to be to say local, some variable name is, and then we can write a arithmetic expression. Now, they're trying to be clever. We use is for variable assignments. We use is for declaratory assignments, and the equals sign is reserved for equality tests. So we could do if ship altitude equals, and that would do the right thing. super annoying for anybody with any programming background, but that's the syntax of the language. We're going to write code for it. So local zero thrust is 9.8 times the ship mass divided by ship max thrust. So ship is a structure that is provided sort of globally, and it is a structure that talks about the current ship. We can access a field on a structure with colon, and so we have some fields like mass and max thrust, and these are going to vary appropriately over time. So every time we look at these fields, they're going to contain the current value for the ship. Now, mass is in metric tons, and max thrust is in kilonewtons. So this is just like we were working with kilograms and newtons. And so if we want to determine how much thrust it's going to take to counteract the force of gravity, that's going to be 9.8 times the mass. If we then divide by the maximum thrust of the ship, that's going to give us the throttle as a fraction between 0 and 1, which is how the throttle works in Kerbal Space Program. And so if we set the thrust to 0 thrust, that's going to cause the rocket to hold in place. Now that's not really interesting to leave it there. So what we're going to do is we are going to, first we're going to print just what that value is, so we have some idea of how much it takes. And then we're going to lock throttle to 0 th plus 0.01, as 0.05 is a little bit more, and then we'll wait 0.1. And so this program should very slowly cause the rocket to accelerate, because we calculated what 0 thrust is, and then we're going to accelerate. We're going to set the throttle to slightly more than that. And actually, as we run out of fuel, we aren't recalculating the thrust, so this will cause it to accelerate faster and faster, but that's fine. We're going to run this program to just figure out how 0 thrust works. Telnet 1 copy path run hover, and the ship is accelerating relatively slowly. I mean, we're up to 5 or 6 meters per second, and it's speeding up pretty quickly. But we still calculated that 0 thrust value is about 0.4, and that's actually pretty nice. That means we have a reasonable amount of space for requesting thrusts that are below our sort of break-even point and above our break-even point. So we can either have the rocket accelerate, or we can actually use gravity to have the rocket decelerate while still thrusting. So if we go back to launch again here, let's go ahead and write a program that's going to be a little bit better at what we're doing than the just bounce forever program. So let's calculate this 0 thrust value in the loop every time, just so we have it. Now, our target altitude is 1,000 meters. Our error in altitude is the current altitude of the ship. That's another field. You can find all the list of fields on the ship by looking up in the documentation. Under vessel is the ship is a vessel structure. Just ship is the current vessel. All right, so what we want to do is we want to calculate what the error is compared to the altitude that we want. and then we want to calculate how we want to adjust the throttle based on what we saw for the altitude, or solve for the altitude error. And I want a helper function here. I'm going to write a function called clamp. The way we write functions in this is we have to declare the parameters on separate lines. No plural. Parameter. So this is just like we wrote a normal function, x0, x1 in some reasonable language like JavaScript, but we don't put them in parens. We have these parameter statements, and then we can say return the minimum value of the maximum value of x0 and x with x1. So we do have minimum and maximum built in, but if we want clamp, we have to write it. So now we can say that we want to clamp our throttle between 0 and 1. And so what this is it's basically what's called a P controller, a position controller, which is we're going to sense the position, and then we're going to adjust our control based on the error in the position. And this, if we extend this concept with standard techniques, we then would next consider the integral and derivative of the error that we're looking at here, and we would adjust our control based on those. And we're not going to go into the full idea of PID controllers. You can Google that and figure out much better control plans than what I'm coming up with. But that's sort of the direction we're going in with this plan. But let's go ahead and try this program and see if it works. So we're going to telnet again. We're going to connect to the rocket. We're going to copy path. Hover over to 1. We're going to run hover. We're going to get an undefined variable error. Because what? Oh, I can't print it because I don't have it up there. Cool. All right, rocket launches, and as we get close to the target, we should start to get less throttle. And so now when we plow through 1,000 meters, instead of having been at 150 meters per second, we were only at we're only at 130 meters per second. And now as we fall back down, rather than waiting to start turning the engine on until we are at the target, we're actually going to turn the engine on a little bit sooner, so we start slowing down first. Now the problem here is that because now we have this 0 position of thrusting to not change our velocity, when we're at the target goal, we're producing the correct amount of thrust, but we're correcting in exactly a way so that we're going to oscillate pretty much the same way as we were oscillating before. This will stabilize out better, and it does have some possibility that we will eventually hit the exact target, but this doesn't quite do the thing that we want. We can do a little bit better if instead of just considering our position, we actually consider our velocity, because that's the thing that we really want to correct, is we want to make it so that we are heading in the right sort of direction. We want to be heading towards that 1,000-meter target, but then as we approach the 1,000-meter target, we want to decrease our velocity. We want to hit a velocity of 0 at the same time as we hit our target. And then if we wanted to be really clever, we could even go that we want to hit a change in velocity of 0 as we hit our target. And then we might be able to stick a perfect thing. But we're not going to worry about that. We're just going to write a quick program that's only going to worry about velocity. So we're going to get out of telnet. We're going to go ahead and open up hover again. And we don't actually care about doing an adjustment based on altitude. What we want to do is create a velocity target. And what we want to do is we're going to say that the maximum velocity we ever want to go is 100 meters per second up or down. And then as we get close to our target, we want that to slow to 0. So our velocity error is ship vertical speed minus the target. And yeah, we have ship vertical speed that we can just read off the sort of ship structure. It has a speedometer. And we could try to have calculated that by having some sort of interframe state or something, but we don't need to worry about it because we can just get it this way. And then we're going to have our velocity fix is going to be our vel error, and then I'm just going to put some arbitrary constant in here. Let's make it 200. So what this does is our velocity error is always going to be between negative 100 and positive 100. So picking 200 here means that we're going to end up with a velocity fix is going to be a number between negative 0.5 and positive 0.5. We know that our even number was around 0.4, at least on a full rocket. And so that's going to give us our throttle range is going to be the throttle range that we have approximately. We'll never go to 100% throttle, I guess, but that's fine. So now this is going to take velfix. We're not going to use the altitude except as an input to deciding what our velocity should be. Right. So let's go ahead and run this. One copy path from the archive, hover over to the thing, then we're going to run the thing, and the rocket launches. And initially this is going to look an awful lot like the last example, where we were doing position targeting. But here we actually slow down a little bit more, and we're going to peak out at around 1,200 meters, and then we're actively going to start slowing down before we get to 1,000 meters. So that means that we're going to bottom out around 900 meters, then in the second wobble we'll peak out at what, 1,060, bottom out at 966. So you can see we're stabilizing out towards our target much quicker here than it looked like we were with any of our other solutions. Now we're down to a 20 meter error on that one. 10 meter error. 5 meter error. Oh, 6 meter. We're like basically cutting our error in half every time we go up or down. And so pretty soon, we're going to get our error to below 1 meter, and then it won't even show up on our still 2 meters. Should be 1 meter here. Now, yeah, we don't even go down to 998. We go back up to 1000. And since our target is exactly 1000, we could conceptually go back down to 999, but no, it looks like we're just successfully hovering at exactly 1000 meters after wobbling a few times. Now, if we explored the idea of PID controllers a little bit more and explored the idea of having, like, picking our coefficients for the different things that we could put places, then we would be able to probably tune it so that we just, in one thing, flew up to exactly 1000 meters and stuck there. Hit 1000 once, and then never again did it change. But that's not strictly necessary for the demo I want to do. We have successfully built a rocket that is now hovering at exactly 1000 meters. So good luck on the Kerbal Space Program homework, good luck looking at all the KOS documentation, and good luck remembering that the way you declare a variable is with the word local and the word is rather than an equals sign, and that you end statements with periods. Have fun.